Donald with Microcom Technologies, and I'd like to thank all of you for attending today's webinar with TP-Link. Today's host is Sean Montgomery, Director of Engineering. He'll be presenting today, and if anyone has any questions, feel free to submit them in the question box, and Sean will answer them at the end of today's presentation. Sean, thank you so much for joining us and hosting today. I am finished for now. The floor is now yours to take over.
Well, thank you very much. Hello, everyone. My name, again, is Sean Montgomery, and I am Director of Systems Engineering for TP-Link. Today, we're going to be talking about Power over Ethernet, and specifically kind of the TP-Link portfolio as it pertains to that. So the agenda will be, again, POE Definition and Technology Overview. I will probably spend 5 to 10 minutes on this. You will probably learn or hear more about POE than you would like to know. Then we'll talk a little bit about POE product categories, and then go over our the TP-Link portfolio. And then the last section will be POE Planning. So really, how, if you have a customer or you're the end user, how do you plan your POE network? And then questions and answers at the end. So Power over Ethernet technology. So Power over Ethernet is simply, and I'm not going to read the slides to you, but Power over Ethernet is simply the ability to drive power to the end devices over Ethernet cabling, so over the twisted pair. So this allows a single cable to provide both data and power to the devices. And really your main categories here of devices are wireless access points, IP cameras, and VoIP phones, so voice over IP phones. There's two different kind of categories, let's say, for POE. So you have a standard. So you have standard types of POE, which is defined by the IEEE. And then there are non-standard POE, which includes passive POE. And this is, you'll see this come from vendors like TP-Link, but usually these are paired with specific devices. And so you have a POE or passive POE adapter that is paired to a device like an outdoor access point. And I'll get into that more in detail here later. So the IEEE, so we're talking about standard POE. The IEEE actually defines the signaling between the PSE, which is the power sourcing equipment. So that would be a device applying the power, and the PD, the power device, which would be your device that is receiving the power. And there's two different types of those. So you have, like a PSE power sourcing equipment. You have, your typical PoE switch or an injector. And a power device would be your typical cameras, again, VoIP phones and access points. So there's 4 different types of Power over Ethernet defined in 3 IEEE standards. So the first one, so type 1 is PoE, and that's referred to in the standard as 802.3 AF. This was actually created in 2003, and you can see in the table below that the max power for that is 15.4 watts. And that is the power that is being at the PSE. So the power sourcing equipment is actually putting 15.4 watts on the line. The power at the PD or the power device would be 12.95 watts. And that's because of cable loss, but that is, your 100 meters or 300 feet of cable, you would still get 12.95 watts. Type 2, PoE Plus, this is 802.3 AT. This goes up to 30 watts. And you see a lot of this today with your dual band access points, your pan, tilt, and zoom PTZ cameras, and some higher end, let's say, VoIP phones with more elaborate screens or video monitors on them. We're not going to talk about type 3 and type 4 today. These are still in the standard. So you have PoE++ or 4 PPoE, which is actually 4 pair PoE. This standard is being finalized now. It should be, I guess, confirmed or accepted by the end of 2017 or 2018. And I think what's neat about this, and it's still coming, but the idea here is to be able to power televisions, docking stations, and things like that that will have higher power ratings. So I wanted to kind of go, so you have types for power sourcing equipment, you have classes for the power devices. So in the power devices today, everything defaults to class 0. So class 0 is 15.4 watts, which is your default PoE standard. If the signaling between the two devices, you can actually, it will ratchet down the wattage down to 4 watts, 7 watts. And if it's a PoE plus device, it can actually signal and say, I need, up to 30 watts of power. The only way to get a class 4 power rating is you have to have active signaling between the PD and the PSE. So the power over Ethernet switch will not apply the 30 watts of power unless it knows for certain that there is a PoE plus device at the edge or at the end. And again, I'm probably giving you way too much information, but there's 2 different modes for PSE, and it's called alternative A and alternative B, or mode A and mode B. And it's it's how the PSE applies type pair. So it depends on which pair of cables that the unit is going to use. One thing to note here is PSE devices only have to support one alternative or one mode, but the power device must support both modes because they don't know which kind of device they're being attached to. So in TP-Link, all of ours are alternative A or mode A. So all of our switches today are that way. So in PoE architecture, there's 2 different types. So you'll hear it called in-span and mid-span. The easiest way to think about that is where is the power being applied to the twisted pair? So is it at the end of the network? So that would be more of a PoE or PoE plus switch, or is it in the middle of the network? So a mid-span would really be a PoE injector. So you have an Ethernet device, that Ethernet is then plugged into an injector. The injector then applies the power to the Ethernet cable and then onto the PD or power device. And then just one quick note on passive PoE. So passive PoE, power is always applied. So there's no negotiation, there's no safety mechanisms. With a PSE device or a standard device, it will actually negotiate to see if it has a PD or a non-PD device attached to it. With passive PoE, there's always power on that line. So that's why we say, with passive PoE, you should never mix match vendors or products. You need to use the PoE adapter or passive PoE adapter that came with the product that was shipped with it. And sorry for that. So that, again, these will be online, so you can read the data or read the text at a later time. So again, so PoE summary, so really the key PoE applications are access points. Again, the main reason there is because of the placement of access points, right? We want to put them on the ceilings. We want to put them in places that we do not have outlets. The second is VoIP phones. It's a nice, clean install. You have one cable, and again, you're not using that extra outlet on the desk or, in the conference room. And then last is security cameras. Again, placement is key here. And this is really why PoE is, such a good technology, is because, you're simplifying your installation process with power and data over one cable. All right, so now I'm going to talk a little bit about power over Ethernet products. So TP-Link has quite a few different products. So I wanted to talk about our PoE injector. So that would be your mid-span PSE device. It's a very popular item today with TP-Link. We sell quite a few of these. So again, it's a mid-span power sourcing device, and it can, apply power to any PoE, standard PoE device out there today. Second on the slide is a PoE splitter. So PoE splitter is an interesting device. So it is actually a PD, so it is a powered device, and then it actually can supply DC power to a non-PoE device. So in the image below, I have it actually powering a small access point. So the small access point itself is not a PoE device, but it can be powered by the splitter. And our splitters have the ability to select between 12 volts, 9 volts, and 5 volts. And then TP-Link has a full line of PoE switches. So I'm going to kind of leave this chart here, but you can see there are managed and unmanaged switches, the port counts, and really what you need to understand when you're picking out a PoE device is what is the budget and what standards does it apply to. So you can see in the fourth column, I have PoE budget. So that is your max wattage that this device can supply. And then the PoE standard. So if you see in some of the cases 802.3 AF/AT, that means it supports both PoE and PoE plus. So it can support up to the 30 watts of PoE plus. And we'll talk a little bit more about this here in a second. So in the PoE switch category, you have managed versus unmanaged. And you need to make that decision when you're doing your planning. Do you need a managed switch, or do you need just an unmanaged PoE, just power to the device? So with managed, what you get is the ability, and I think this is the most key ability, is to be able to bounce the port or disable and enable the port so you can reboot the device at the other end. Let's say you have a security camera, every 3 months for some reason it gets stuck. You can reboot it or power cycle the device from the managed console of the switch. The other things you can do is you can set priorities. So if you oversubscribe your power over Ethernet budget, you can decide which devices that you will drop off. Also, you can do time ranges, so you can say that I'm only going to apply power during business hours to, let's say, your access points. So your access points would only be after business hours, your access points would be turned off, and then you would probably set a profile that your security cameras are always on and your phones are always on. On the unmanaged side, you don't have that ability. The only ability that's in the unmanaged switches today is just priority, and this is built in. So with this, port 1 has the ultimate priority, then port 2, then port 3, and then port 4. So what would happen is if you oversubscribed or you were using too much power, it would go in order, and it would probably drop off port 4 at that point if ports 1, 2, and 3 were using, up to the maximum power of that device. And then TP-Link power over Ethernet access points. So again, we have a full line of enterprise access points. These are software controller, free software. But really, the key here is they are power over Ethernet. So easy placement, easy installment, again, easy management. If you, again, put it with a managed switch, you can reboot the units. You can do anything you need. Again, time and priority as well. All right, so this is where I want to spend most of my time, is PoE planning. So when you're planning to use PoE in your network, a few questions you need to ask. First, how many devices are you going to need to power, right? The second, which I think is the most important, is what is the distance from the location of the devices? Remember that you are limited to the 100 meters or a little over 300 feet. So if you have a warehouse that you're trying to do security cameras, you know, you might only be deploying 4 security cameras, but they're not within 300 feet of each other, right? So you would actually need to do 2 or 3 power over Ethernet switches, or in, you know, a lot of cases here, you would use a POE injector if you don't want to use a switch. You don't want to put a switch to power that one far-off device. The second is, what is the power requirement of each device, right? You need to, and almost every manufacturer that has PoE powered devices will tell you what the power rating of that device is. Do you need PoE plus? If you need PoE plus, then of course you're going to need a PoE plus switch or injector to be able to do that. Fourth, is it unmanaged or managed? Do you need, you know, is it needed or desired? You know, I would say for a very simple, in this one restaurant example, if you're just having a couple access points and a couple IP cameras, you can probably get away with an unmanaged switch. When you're starting to talk about VoIP phones and very large deployments, I would go for a managed switch. But again, it's really what is your or your customer's desire when it comes to manageability of their PoE devices. And then last, you know, possible expansion. So you could buy, in the example 1, you could buy a 4-port, you could buy an 8-port switch with 4 PoE ports, but is there going to be any expansion in the future? Will they need more PoE ports? Will they need more wired ports? So really kind of think of all those things before you make your decision on, you know, which device you want to put in the network. So I was just going to walk through a couple of examples. So example 1, again, is a small restaurant would like to deploy 2 wireless access points and 2 security cameras. And then example 2 is going to be a small office that wants to deploy 2 wireless access points, 16 VoIP phones, and 2 security cameras. So what I did is I went out and to our website and pulled our power tables off. So the restaurant wants to use the EAP 225, which is the AF standard, and we pulled out 10.15 watts. The EAP 330 is the PoE plus standard, and it pulls 17.7 watts. And then I just went on and just chose a random security camera and looked up its specification. It was 7 watts, and then again a random VoIP phone for 6.4. So in our example 1, in the restaurant, so we have an EAP 225 times 2, an IP camera times 2, so that gives you a total budget of 34.3 watts. So if you look at my power budget column, you can see that any switch that TP-Link carries today would cover this. So then you have to ask your questions, you know, what is my expansion, and also reach. I'm thinking in a restaurant, you very rarely have restaurants that are very large. If the 300 feet is not going to cover, but you know, you might have a large restaurant that you need a second switch or an injector. The other piece here is, again, how much expansion will they need? Or, you know, do they have a point of sale system where they need, you know, 6 or 7 more hardwired devices to the network? So again, take all that into consideration when you're picking out your switch. You know, for me in this case, you know, again, depending on what the answers to those questions are, I would probably pick the SG108PE. It gives me 8 ports with 4 PoE with a 55 watt budget. And then example 2, again, is the EAP 330. So that is our high-end access point. So it's a dual band AC 1900 and very powerful. So it's pulling quite a bit of wattage. You can see, you know, if we go through everything, we have a total budget of 151 watts. And the other thing, we have 20 ports that we're taking. So that really, at that point, that kind of says that we need at least a 24 PoE port switch or higher, depending again on expansion. So here, you know, I would probably pick the T1600G 28PS, or I would move up to the T1652PS for this device. And again, it depends on the level of manageability that you need, but that's kind of, gives you kind of guidelines. And again, in this scenario, I don't know the size of the building. If I had a very large building, I might need a second switch or an injector to reach those devices that are far away. So this really concludes my portion here, or at least the overview of the presentation, and I can answer any questions that anyone might have.
Thank you very much, Sean, for that wonderful presentation. It looks like we do have some questions here for you. Let's get started with the first one. Here we go. Is it possible to run a router with solar panel and a chip card with your devices?
I don't know exactly what a chip card is, but if you, depending on your router, if you can supply 12 volts, and depending again on the router from 1 amp to 2.5 amps, then yes, that would be possible.
Thank you very much.
Really,
go ahead.
Well, I was just going to clarify. So it really depends on your solar system, but if you can supply a constant 12 volts at, again, at the power rating of the router from, 1 amp to 2.5, then that should not be an issue at all.
Thank you, Sean, for that. I'm going to go ahead and go on to the next question here. Let's see. We have someone here that says, I have a remote location that cannot connect to internet or power, such as campsites. Can you address that?
So I guess that would go back to the power, to the solar thing. But if you don't have access to internet, or I guess I somewhat don't understand the question. I think you can get power from a power over Ethernet perspective. You have to have power sourcing, so you do need AC power somewhere in the network. But if you're a campsite, I guess you go back to the solar question, but then what is your internet connection at that point? You're going to have some kind of wire somewhere, unless you're doing completely wireless.
Okay,
so
great.
It would have to be solar at that point. That would be my only, unless you have AC power within 300 feet of the device.
Okay. I've got a next question here. What is the logo on the page where it shows IEEE?
So that is the IEEE, which is International Engineering something. I would have to look up the actual acronym, but it is the engineering task force that writes the standards for most Ethernet and Wi-Fi standards.
Thank you. We could look that up too, but yeah, thank you. Next question for you. Do you manufacture PSE and PD devices?
Yes, TP-Link does do both. So all the switches and injectors would be PSE devices, and the access points and the splitter would be PD devices.
Thank you very much. A couple more questions for you. Are you considering venturing into the broadband market at all?
TP-Link is very active in the broadband market. So we do have cable devices, DSL devices, fiber devices. Really our main thing is in-home connectivity and SMB. So if it is a connected device, more than likely TP-Link has a solution for that.
Excellent. Thank you very much. I think we've got one last question here. In regards to the PoE injector, does one need one PoE for each camera?
Yes. It's a simple yes.
Thank you very much. And Sean, thank you so much for making your presentation and providing answers to those questions. And also, I'd like to thank everyone for attending today. And if anyone has any questions, please feel free to contact your sales rep or email us at sales@microcomtech.com. If you wish to view any of the products mentioned or shown today, please visit us at www.microcom.us. And remember, this webinar presentation has been recorded and it will be uploaded to our Microcom YouTube channel so it can be viewed again. Thanks, everybody. Thank you, Sean. Appreciate your time today. Everyone have a wonderful rest of your day.
Thank you.
You're welcome.